Yeah, start.
So, hey all guys, good morning, good afternoon, everyone. The today's session is going to be about Glacier and Monterey, one of the Trident platforms. This platform is most particularly used by Facebook customer mostly. But yeah, let's
Hey Ashwani, I think you accidentally muted yourself.
oh sorry, thanks. I unmuted. Can you hear me now?
Yeah.
Yeah. So yeah, let's start with the presentation. So this slide just shows how the evolution happens through different chips. Like most probably, we are going to focus only on Tomahawk 3 and 4, which is used by Glacier and Monterey respectively. So looking at the chip capacity for TH3, it is 12.8 Tbps, and for TH4, it is 25.6 Tbps. Uh, so the throughput is 32 cross 400 gigs, and it can also be seen as 256.25.6 can also be seen as 64 cross 400. And the number of SerDes has basically doubled between Tomahawk 3 and TH4, which is 256 SerDes in TH3 and 512 SerDes in TH4. So yeah, this is just the difference between TH3 and TH4 as we are going to focus on it. So it's the first three are basically the same. And what we have to focus more on is the logical port limitation. In TH3, it is 18 per pipe, and for TH4, it is 4 per core. And the number of pipelines are different. In TH3, it is 8 pipelines, and in TH4, it is 16 data pipes where the data comes in, the packets come in, and two such data pipes would make one packet pipe, which is where the packet is being processed. So 8 data pipe, um, and the cores will be 4 cores, and these 4 cores will make us one pipe. This 8 pipes. So four of these cores will make one pipe. So similarly, it's the 4 cores will make one data pipe, and two such data pipes will make us one packet pipe. So the number of SerDes per pipe remains the same between TH3 and TH4. Per pipe, it is 32 SerDes per pipe. Yeah. So as I said before, Glacier uses TH3 or J2 plus, and Monterey uses TH4. You're looking at the chassis number, 7368 is Glacier and 7388 is Monterey. Yeah, these are the components of Glacier, where we have one chassis, one switch card. This is a new addition. This is where the ASIC will be mounted. And we have two different line cards. One is Perry and Grinnell. The number of ports and speed differs between these two line cards. There's one supervisor and one BMC module. So looking at the Monterey components, it's the same basically with chassis, switch card, and supervisor BMC modules. The line cards number has types of line card has increased by one more, like 3 line cards or types are there. And Blanco, this is mainly used by FB. So we'll dive into Glacier. So yeah, as I keep telling that Facebook is the big customer of Glacier. So they were using 7304, one of our products, Inyo, which has 128 ports, which can operate at 40 or 100 gig speed. Uh, Looking at the Inyo chassis, which is in the picture, it is 8 RU, and it has four line cards with 32 ports, and each line card will have 3 ASICs, which will count to 12 ASICs. And the chassis is itself is entirely big. It is 8 rack units, and the power consumption is 12 kilowatts. So the same port density is achieved by Glacier with 8 line cards and 16 ports. The same port density is achieved already, and with just one ASIC, which is in the switch card. As I said, the switch card only has the AC, not the line cards. And the size is also considerably reduced to 4 rack units, also reducing the power consumption. So this is the comparison between INEO product and our Glacier. So if we look at the Glacier chassis, there is one difference that everyone can make out, like by just looking. We can see that the line cards are vertically mounted here with all the handles so that we can remove and insert easily. So there are 8 line cards in this Glacier chassis. Um, yeah, but meanwhile, just feel free to stop me if you want, if you have any questions or anything, so I can stop and explain. Yeah, so yeah, this is just reiterating that Glacier still uses TH3 chip. This can also be seen as 32 cross 400 gig ports. So this is implemented with one Blackhawk core, which is a 5 core. It has 8 SerDes, and each SerDes can operate at 50 gig, 25 gig, and 10 gigs. So these are certain permutation combination how the 400 gig port can operate in different SerDes speeds. Okay, so as we saw this chassis already, it's already 4 rack units. There's one switch card with TH3 chip, the ASIC, one supervisor, and 5 fan cards, and 4 power supply slots. As I said, Glacier has 2 different line cards. They are vertically aligned, and with it has gearbox. We'll see why gearbox is there later in the later slides. But yeah, there is two types of line cards. One is Perry, which is 16 ports, which can operate at 100 gig QSFP ports, and Grinnell, which is 4 cross 400 gig QSFP DD ports. These are just 2 different form factors. Okay, so this is the front view of the chassis, which we already saw. There is 8 line cards vertically mounted with the handles for OIR, EC OIR. Sorry, EC insertion and removal, not OIR. And this is the rear view where it has 5 fan cards and 4 PSUs. And the switch card is somewhere in middle behind these fan cards. So this is not, switch cards are not hot swappable. Switch card and supervisor are not hot swappable. We would need to remove all the fans to get the switch card out. And there are like 4 PSUs. In this picture, there's only 2 inserted. So yeah. Okay. So it jumps out. Okay. So I was telling that line cards would have gearboxes. And the purpose of gearbox is that if you see the picture here, we can see that 100 gig transceiver is inserted in the transceiver slot. And since there are 4 lanes, it is split as 25 gigs in this picture. So what can we do? But we know that the SerDes is operating at 50 gigs. So if we are mapping 25 gigs to 4 different SerDes, which is operating at 50 gig, we are reducing the throughput by half. So in order to overcome that, we would need to make this 25 gig into 250 gigs, so that we use the full capacity of the SerDes, and also we achieve the transceiver's speed. So this is taken care by the gearbox in the line card. So what the purpose of gearbox is that it will map 250 gigs as 425 gigs, or vice versa, 425 gigs as 250 gigs. Any questions? I'll pause here for any questions. All right. So it's the same here in 200 gig mode. Here we are already operating at full capacity, which is 50 gig, and 200 gig transceiver is inserted in the slot. So all the 4 SerDes, we said that 4 SerDes per pipe, and it's going to use all the four SERDES, and the corresponding odd port will go unusable. We'll see this how this goes unusable in the next slides. But yeah, the one of the ports will go unusable. This is one such limitation, uh, where if we are operating, we can just have four active interfaces per 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 pair of QSFPs. um, Glacier details, and this is, yeah, this just reiterating that it has one supervisor, one switch card, and 8 line card slots. Also, we know that switch card is the one which is housing the ASIC, so we don't have any interfaces there. It's not like Fabric, and it's not hot swappable as well, because we have to remove the fans and everything before we remove the switch card. Yeah, this is about supervisor. These are all self-explanatory. This is also not hot swappable. We have two management SFP. One is RJ45 and the other is SFP 1000 base or LX 1000 base SX or LS. Yeah, this is about this Perry line card type. So this line card has 1600 gig ports, QSFP, and following SerDes speed can be supported. And it, like I said before, the LCs does not have any ASIC compared to the other LCs, traditional LCs, and also it has gearbox chips converting 50 gig PAM to two lanes of like uh, 25 gig 25 gigs.
Sorry,
uh,
Ashwini, can you just go back to the previous slide? I just wanted to add a couple of details here.
yeah.
Yeah. So one thing is, I think a lot of us know this, but I thought I'll bring it to everyone's attention. Please note how the services are mentioned in lowercase g, right? But the interface speeds are mentioned in uppercase g. So in the line here, the service is 10G, that's 10 lowercase g, that is the speed of the service. And the 10 capital G, that's the speed of the interface that you are actually configuring. So when you go to an interface and say speed 10 gig, that's capital G. But for it to work as a 10 gig interface, you will need the service to operate at a certain speed. That is denoted by lowercase g. Okay, so
Mm.
just one thing I want to bring about here. Uh, the second thing is uh, you will find speeds sometimes that have a hyphen. Let's say in the third bullet point here, you have 50G and you have 50G hyphen 1. The number after the hyphen indicates the number of lanes that it will have to use. Okay, so sometimes if your service can operate at 50 gigs, you need one lane to achieve 50 gigs speed. But if it's running at maybe 25 gigs, you need two such 25 gig lanes to make up 50 gigs. So the number after the hyphen tells you the number of lanes required to achieve that speed. Yeah. And the last thing, like what Ashwini was saying, was that this is not a traditional line card. The line card that we have seen so far in the modular, they all have an ASIC and they have an interface. But on this particular line card, there is no ASIC. There are just slots for your transceiver to be inserted, and then these are all mapped to the ASIC. Okay, so that's a little different. Yeah. So any questions on this? Okay, Ashwini, yeah, over to you.
Thank you, Sujit. Yeah. So yeah, I missed to say this. This is the number of lanes after the hyphen, and yeah, there is difference between capital G and small g. Yeah, there is one TOI where we need some change there. So thanks for bringing that up, Sujit.
Just one question. If we can just go back to the number of servers on TH3 itself, there was one diagram there, right? Or that information was there somewhere.
Mm.
This one, I think. After that, so Yeah. So
This
okay, so how many SERDES do we have on this TH3 total?
uh, 256.
Okay, so it would be 256 and 32 would be going to each line card, correct?
Yes.
So can you go to the next slide now? One more, where we had that diagram of the block diagram. Yeah, this one. So let's say each line card will get 32 SERDES, correct? And each line card has got four Babbage gearbox,
Correct.
right? So 32 divided by 4, around 8 would go to each Babbage, correct?
Uh, yes.
So,
The Babbage is also split into cores. It has two cores in the Babbage. So four for each core.
okay.
Yeah.
So it would be 4 for each core. Okay.
Yeah.
So now when we are changing the SERDES speed
Mhm.
um, that is required for the interface, we are changing the SERDES speed between Babbage and the transceiver slot, correct? It should be this 25G would become say 10G or 50G depending on what we want.
Uh,
And
we
the
are
back
changing
end
the
will
SERDES between TH3 and Babbage. SERDES is between TH3 and Babbage. This is just a transceiver slot between the line card and the ASIC. This part is line card and ASIC. This is ASIC and uh,
okay. So when we are
five
changing
The,
the SERDES, sorry, go ahead.
five core. Maybe I'll show it in the next slide. It will be more clear, I think. Uh, it's gonna be
but
wise
yeah, I think
before we.
Sachin, what Ashwini is saying is actually correct here. Whenever we talk about changing the hardest speed group, right, that is for the SERDES.
Okay,
And the
it should be
SERDES is what is
between.
connected to the 5 core on the ASIC.
Okay, okay, between your ASIC and this, the one which is on the ASIC itself.
Yeah.
So yeah, so the TH3 here in the slide we're looking at, that is the ASIC that has your 5 core. The Babbage here is the gearbox,
Mm.
which is on the line card. So in any of the platforms, right, when we change the SERDES speed and all of that, that is for the SERDES which is on the ASIC.
Okay, because just now I saw because I was here because if you see earlier it was 25G between Babbage and line card, sorry, transceiver. That's changed to 50,
Yeah.
but the backend remained 50 always.
Yes, so that depends on the kind of transceiver you insert. Now, in this case here, in this slide, the transceiver here is a 100 SFP, right? This is a 25 gig, sorry, a 100 gig transceiver. In the next slide, I think, Ashwin, you can go to the next slide. I think it's a 200 gig SFP. Yeah,
Mm.
15 to 4 lanes
Okay, so this four lanes are coming from the transceiver, but when we change the
Correct.
speed, it changes the backside. I mean, on the ASIC itself.
On the ASIC.
Okay,
Yes.
okay, yeah, thank you.
Yeah. So okay. So we were here. Grinnell line card. So this one has four ports and QSFP-DD, which is 400 gigs. Uses this also has the retimers, that is gearbox and chip. Again, the SerDes speeds are mentioned here. Whatever is supported by 25 gig, it can operate as 50 gig in 2 lanes and 100 gig in 4 lanes. And the same for 50 gig. One lane is 50 gig, 2 lanes is 100 gig, 4 lanes is 200, and 8 lanes is 400. So these are the speed supported and the SerDes speed supported. Yeah. So this in this slide, like I said, they are not hot swappable. So how can we figure out if these are removed? So for that reason, we have added new unseated reload cost. So when we check this row reload cost, it's going to show this reason: the system rebooted due to card being unseated when the switch card is removed. But there is some SED watchdog timer before expiry of which the supervisor card gets reseated. Then that also might show the same reason. Otherwise, if the ACD watchdog timer restarts or expires before that, it will show as a normal watchdog reload. And any upgrades on these two cards like FPGA or CPLD upgrades, it's going to power cycle the system. Are we clear with this? Okay. So yeah, coming to the very important part of the TASI session, the port mapping is very important here. So as I said, there are going to be 8 line cards, and there are pools at which the line cards are going to be mapped, and also there is going to be many restrictions when the interfaces are becoming active or inactive. So let's look at this diagram. We can see that line card 1, 2, 3, 4 is mapped to pipe first 4 pipes, and there's a power in between. So the rest of the line cards 5, 6, 7, 8 are mapped to 4, 5, 6, 7. So these there is one-on-one mapping between the line card and all the 4 pipes. So the line cards interfaces are going to be split across the 4 pipes. So not just one pipe is going to have interfaces from line card 7 and line card 6. It's not like that. Every pipes, every 4 of these pipes is going to have interfaces from line card 7. They're going to be split across. And the same from this side as well. Every line card 1, 2, 3, 4 is going to be there in all these 4 pipes. So in order to we can check the lab. It'll be more clear there. Let me know if you're able to see my item screen.
Yes.
Yeah. So the command to check this is show hardware logical port pool status. So this is the command to check the pool status. So so we have 8 pools here. The same can be seen here as well. 8 pools are there. And as I said, there is a limitation on number of ports, logical ports that can be configured. The limitation is 18. And we can see that line interfaces from different line cards are mapped to each pool. Now look carefully at this. Can anyone tell me why line card 5 is mapped to pool number 1, whereas we see line card 5 is mapped to pool number 4, 5, 6, 7? The answer is right there on the screen. So anyone can try why we are seeing line card 5 on pool 1. Okay, somebody is typing. Can't see it.
That was just me explaining the logical port limitation. But we can go on.
Okay, so yeah. So if you look at the show module of this chassis, we see the first card is supervisor. So the line card actually starts from slot 2. So this is slot 2 is considered as first slot. That is why line card 5 has come into pool number 1. So we see 2, 3, 4, and 5. Then the way the ports are mapped looks like it's pretty random, but we can see that there is 16 possibilities here, and it's 3/5/1 to 3/8/4. There is one more 16 possibilities here, and this is 16 here, and there is another 16 here from line card 5. So we have 64 different interfaces which can come up, but out of which this configured has taken into account that these are not still split. It's just taking the 4 interfaces, unsplit interfaces. It's just C16 is configured and 2 are free, which equals to the max logical ports 18. So yeah, so only 18 can become active for this pool. So in case assume there is line card 2 inserted, and transceivers are all inserted in this 2/5 and 2/8 slots uh, until fully 2/5, 6, 7, 8. And line card 5 is inserted, and transceivers are there in 5/9, 12, 9, 10, 11, 12. Uh, the priority is given to line card 2 ports. So all the 16 ports here will come up, and maybe one or two can come up from this one. I'm just assuming that these two line cards are not there. So the priority is given to the lower number of line cards, and only then the priority goes to higher number of line cards. So it's the same between 2 and 3. If 2 and 3 is there, only 2 ports can come in, and 3 ports are going to come up after the 2 ports are up. So this is one such limitation. This is one behavior where priority is given to the lower number of line card number, lower line card number or lower interface number. Any questions here?
Just one more observation. So when you look at the pool, there are 8 pools, and there are interfaces listed against each pool, right? This also implies that all the interfaces listed against that particular pool share that hardware resource, right? So they are competing for the same hardware resource. So there is a possibility that you may be out of ports. So let's keep that in mind. So whenever you change a service group, or whenever you change the speed, or when an interface comes up, there is contention between all the interfaces that are a part of a pool. Yeah. Okay, and we'll see that later on. Yeah.
Yeah. Maybe I can just I since I have the configuration already, mode already. So now it is configured as 16 and free is 2, right? Let's try adding more interfaces and see if what will happen if we cross the 18 mark. So I'm just going to apply 50 gig on all of these interfaces. So there are like 251, 261, 271, and 281. I'm going to apply 50 gigs on this. Like, let's not worry if it goes to error disabled or whatever, but let's see what happens. Okay, so it just says that the compatibility is not there. It's going to show us error disabled for sure. Show interface status error disabled. So these all went as error disabled. So if we see the same command again, hardware logical port pull status, it says 20. We have configured 20, but the maximum is 18. So what error this will throw? So logging. So yeah, see, while we configured the speed as 50 gig, it intimated as saying that these two interfaces are going to become inactive, but we didn't touch any of the line card 5 interfaces. We just changed configs on line card 2 interfaces. So if we are configuring anything on a lower line card, it will definitely impact the higher line card. That we can see it clear here. And what will happen if the pool is exhausted? We get these two logs. It just says out of logical ports for this particular interface which went inactive right now when we configured the speed. So in older codes, it just says hardware resources full, but this is 4.31 and it says out of logical ports here. So any questions? All right. Moving on. So we saw there are two different line cards and two different form factors which are coming into picture. So just minimize this one for now. So the Sperry line card, which has 16 interfaces, 1600 gig interfaces, is split like this. It is split as QSFP 28 and QSFP 56 pairs. It is split as pairs of QSFP 28 and 56, whereas the Grinnell line cards, which had 4 cross 400 gig transceivers, it will split as just QSFP DD 400 and the other form factor is OSFP. The model names are different for these two. There's 4D and 4P. For OSFP, it is 4P. For QSFP, it is 4D. Yeah. So, let's look at this diagram. Sorry, I'll just maximize this one. Yeah. Okay. So let's look at this diagram. So this is mapped to two different interfaces. This is a pair. QSFP 28 and 56 is a pair, and ET 2/1/1, 2/2/1 shares these hardware resources. These pair will have hardware resources shared, and they map to the same core, which is Babbage core on the line card, and this in turn gets mapped to the Pi core. This is what Sachin was asking before. So this is the Phi core where the SerDes is mapped. These SerDes are all, these four green lines are all 50 gig in speed. So, and this is a different, these two are pair and these two are a pair, different pair. So these 231 and 241 will share resources, whereas 211 and 221 will share resources. Yeah, let's take a look at the TOI for that. Okay, I have one diagram which will explain for explanation. So let's assume QSFP 56 is 200 gig speed here, and QSFP 28 is 100 gig. So each port will have a pair of 100 gig and 200 gig ports. So we'll see how the speed and inactive ports are going inactive because of this. So if QSFP 56/1, it means that even port /1, which is in this case, it will be 2/2/1. So we can also see show interfaces interactions. ET 2/2/1 interactions. Yeah. So if we see here, what will happen if 2/2/1 is configured as 200 gig across 4 lanes? So each lane will operate at 50 gig. So if we check the diagram, we are seeing this part. So 50 gig, this one. So all the other 3 links will be used for this entire 50 gig. And what will happen is, once this link becomes inactive, that is 2/2/1 becomes active, all 3 other links are dependent on the first one speed, so they all go inactive. All of these 3, 2/2/2, 2 and 2, 3, 4, they will go inactive. And since all the 4 lanes are used, which will use the all 4 links of SerDes as well, we don't have any other interfaces that can come up. So this entire 2/1 will go inactive. Just let me know if something is not clear. This is going to take a while if you're trying to explain.
So just to add to what Ashwini is saying here, if 2/2/1 is configured as 200 gig, we need 4 50 gig lanes, right,
Yes.
to be able to achieve 200 gig. So when
Yes.
Ashwini says that 2/2/2, 3 and 4 become inactive, they are still up, they are still carrying traffic, but they're inactive from a logical port sense, where they can't become logical ports, right? But it's still active, it's still carrying electricity, still carrying a pulses. Okay, but from a logical point, it's inactive because I can't have an interface called 2/2/2 and give it an IP address, because it is also using its electrical signal for 2/2/1 for 200.
I don't know if that's still biased because when I go to
Yeah, any questions on this?
when I go here, I don't charge for some reason. It's not even with the extra stuff.
So if you look at the Babbage, like Ashwini was saying, the Babbage is split into two cores, core 0 and core 1. Now, core 0 has four links that go to the ASIC, core 1 has four links that go to the ASIC. Right. So what happens is that I only have four links per core, which means that interfaces 2/1 and 2/2 have to share these four black color links. Now, if those four links are utilized by any interface, the other interfaces in that pair will be unusable. Any questions on this?
So basically, Sujit or Ashwini, when we are saying, yeah, can you please go back to diagram?
Sorry, this one? Yeah.
Yeah. So when we are saying that we are using all 8 red color surfaces for 2/1, so 2/2 will not be available, right?
No. We are taking a look at 2/2/1. That is QSFP 56. 56 means let's assume 28 as QSFP 28 as odd one and QSFP 58 as even port. So in this case, 2/2 is the even port. So
Mhm.
what will happen? The TOI suggests what will happen if the even port's first lane is configured with 200 gig.
Mhm.
How will we split the 200 gig? We will need 50 gig, which will run across 4 lanes, right?
Mhm.
So what will
Yeah.
happen is uh, 2/2/1 will do the job, and rest of them will support. Like Sujit said, they are going to be they're going to support 2/1. They will also run 50 gig, but we cannot just configure them because it is working with 2/1 to push that 200 gig. They all will go inactive. These 3 links will go inactive. So these 3 links will also in turn use three of these SERDES. And 2/1 is already using one of the SERDES because it is active. So
Okay.
4 SERDES links are exhausted for this core, right? So the
Mhm.
rule is we can have only 4 active interfaces per pair.
Mhm.
So the 4 links are already active. Like 4 surds are already gone. So
Mhm.
we can't use the odd side of the pair.
Okay, got it.
Yeah.
But Naveen, to answer your question, this is also the same if we want to use the odd interface. In this case, if we want to use 2/1, then
One.
there's a possibility that 2/2 may be inactive because all the 8 red lines are mapped to the
Mhm.
same 4 black
Black
SERDES.
lines.
Yeah.
Yeah. Okay. Yeah. Then also there will be some preference, right? If we configure 2/1 and 2/2 with the same, which will come up? I believe the one should come up or two should come up.
That
That
is where we
depends
have
on
the
the
interface.
interface speed.
We also have the
Means,
interface priorities here, where the lower
yeah,
number is
yeah.
given the priority.
Lower will
Yeah.
be given the priority, right? So 2/1 will come up if we configure with the same speed, right?
Yes. And
Yes.
I think that we'll see that a little later. There is a
Uh,
concept of interface priorities as well.
mm. Yeah, thank you.
Yeah. Any other questions? Okay. So we will see one more speed, just to be we are getting clear with that. So now it is 2/2/1 is configured with 100 gig. For 100 gig, we would need 2 lanes, which then it will operate at 50 gig speed. So if we need 2 lanes, then first one 100 gigs. First one 2/1 is obviously active with 50 gigs, and the other 2/2 supports it. 2/1, and so because 2/1 is there, 2/2 goes inactive. But we have just used 2 links of the SERDES now, right? So we also have the option of 2/3 uh, can come up. So that is why we see 2/2/3 is limited to 100 gig. So just in case 2/2/3 uses that, then 2/4 will go inactive. That's the reason it says 2/2/4 becomes inactive. So just when any even at least one of these QSFP56 interfaces are going to be there up, then the entire corresponding odd interfaces will go offline. So that is what it's mentioned here. It's also mentioned in the TOI for below speeds. That is now we are seeing 100 gig too. For below speeds, if we configure QSFP56 port, it inactivates the corresponding QSFP28 port in the pair, which happens in this case as well. So this is a very good TOI where we can, if you're confused about which interface will come up or go down, we can just go over this TOI, and this will explain a lot more clearly than everything. Like we can see which interfaces will go up, and there's also what I was mentioning is the TOI that needs changes. The speed group compatibility. When we do hardware speed group status, we're going to see the SerDes speed. So this is going to be small g, not the capital G. So yeah, the compatibility speeds are all small g. It's wrong in the TOI. Maybe we need to change it. Yeah, that's it. That's it for this 73, 68, 16C. Just let me know if you're good with this, or if you need to look at more speeds, then we can check here now.
Just one thing, so I can't run like 2/2/1, 2/2/2/, no, sorry, 2/2/1, 2/3/1, 4/1, like that. Four of them in 100 G.
Okay.
Is that easy?
Sorry, I don't.
So, like looking at this output, right, 100 G-2, the speed for 100 G-2. If I can't run. If I run 2/2/1 in 100 G, then 2/1/1 goes inactive, right?
Yes.
Uh,
2/1 goes inactive. Like
yeah,
all 4.
2/1.
Yeah.
Yeah, all four. So I can't have like all four interface at 100 G speed at the same time, correct? Because if I put 2/2 in 100 G, 2/1 would go inactive,
Yes.
right?
That's right. Yeah.
That's it. Yeah.
So, just to summarize, Sachin, yeah, what you're saying is correct. Uh, this limitation exists because there is an oversubscription of the number of logical interfaces, but we are limited by the number of SerDeses. Okay, so the 5 core is mapped to the Babbage gearbox. And if you see the Babbage gearbox, there are 2 cores, right? Core 0, core 1. The black SerDeses go to core 0, the blue SerDeses go to core 1. Now, the black SerDeses go to core 0. Core 0 is mapped to only 2/1 and 2/1. The blue SerDes is mapped to core 1. Core 1 is mapped to 2/3, 2/4, which means that between 2/1 and 2/2, there are 4 lanes in each QSFP, right? But all those 8 lanes can only share these 4 black colored SerDeses. So if 2/2 takes up 100 gig, the odd interface is unusable. Or vice versa. If 2/1 takes it up, then the even interface can't take it anymore.
Yeah.
So for
Sorry.
I'm sorry. So for the maximum number of logical ports, we can configure it to 25, right? And we can get all 8 red and orange lines active, right? And
No, the
total 8 ports.
maximum is 18 logical ports.
Mhm.
Maximum is 18 logical ports. I'm not sure what is 25, but all these ports are going to share the hardware resources, like irrespective of the number of line cards. The 2, 3, 4, 5 in the same pool are going to share the hardware resources. This is just explaining inside the line card what will happen if 2 ports are mapped in pairs.
Mhm. Mhm.
Okay, so in this like this is between the interfaces in the same line card. But this hardware logical port will show interfaces between the line cards.
Multiple line, 4 line cards,
Yeah,
right?
yeah, the 4 different line cards. So
4 different line cards.
if you say 16 of these interfaces are up already,
Yeah.
you have only 2 places that can be filled. So that can come from any of these 3 line cards.
Mhm.
Okay, again
These are
the
4 line cards of 2, 3, 4, and 5, right? Four
yes,
line, 4 line cards, and each line card is giving 5 to 8, means 4, 4. So 4,
yeah,
4 is a 16 total, right?
yeah, yeah,
4, 4 is a 16. So that only I said, right? If I want all these 16s in, let's suppose these all 16s are going to core 0 in this diagram. So if, and backend it is having 200 gig total SerDes speed, right? 15 to 4 to 200 gig.
okay,
I
You're
think
getting
each
my point?
core port will be to one baggage.
Huh?
I
Correct.
think
So
Huh?
a
four
set of
ports go to
core ports.
one core.
Huh?
A set of 4 ports. No, no, sorry, sorry. The 18 limitations is per pipe. 18 number of
Hmm.
logical limitations is per pipe. There are 8 such pipes. If you look at the drawing that Ashwini was talking about, there are 8 pipes, right? That
Mhm.
is, so each pipe here, the pipe 0 to pipe 7, each of the pipes can have a maximum of 18 logical interfaces. Okay. Now, let's say we go to pipe uh, 0. Now, pipe 0 is maybe pool 1, right? On the output over here in the CLI, it is pool 1. That's pipe 0.
Hmm.
And in pool 1, I have all these interfaces mapped. That is, on line card 2, interfaces 5 to 8. On line card 3, 5 to 8. Line card 4,
Hmm.
5 to 8. And line card 5, 9 to 12. Okay.
Yeah.
Now, these can, between these 18 logical ports. Now, even within that, within the line card also, now let's say within line card 2, I have 82/5/1 to 82/8/4. Within that also, then we zoom in to this limitation here because the core is mapped to 2 cores uh, on the gearbox, and then there also you have an odd and even pair. Okay, so each line card is broken into an odd and even pair, and in that odd and even pair also they share that core as a resource. The line card they share the Babbage core. So even there is a further limitation of 4 services. So think of it as a layered uh, limitation. One
No, no,
is
that is correct, Sujit. So what I was saying, so we from the CLI we can see that 16 ports, right? Though they are coming from different line cards, right? 4 different line cards. So 16 ports are coming to a single pool, right?
correct.
And those are, let's say, going to core 0.
No,
Those all.
they're
no,
not going to
no,
go there. No, they are
Okay.
all now. They will go to a pipeline. In one pipeline, there will be 8 such cores, 5 cores, different
Okay.
5 cores.
Mm-hmm.
Now, in that, on line card 2, say 2/5/1 to 2/8/4, that will be mapped to 5, 6, 7, 8, two such Babbage cores.
yeah. To understand it more clearly, like we have, you can see this big diagram.
Yeah.
That is just a snippet of one of the interfaces from here. So we have four Babbage cores, which is split
Mm-hmm.
into two.
Ashwin, can you go to the slide share mode, I think, because then it will be
Okay,
easier for us.
Mm-hmm.
okay, yeah.
And
So
collapse that CLI maybe a bit, little bit. Maybe just increase the width.
now is it okay?
Yeah, better.
Yeah. So if you see, this is within the line card. Like we said already, this picture is within the line card. So we can see how the competition is between these two interfaces only. Because they are
Mm-hmm.
mapped in pairs. Each pair is mapped to one core. So we have 4 such entire Babbage cores, and those Babbage cores also they are split into two different cores. So there will be like competition between the interfaces itself for them to come up. before we speak about these 18 logical ports. Only then we count how many interfaces per line card they are up, and how many logical ports they have exhausted per pool. Then we count the number logical ports numbers. Am I clear? Or
No, it's okay. Okay, thank you.
Okay, so but maybe just to summarize this, right? The first contention, think of this as a line card. This is line card 2. Okay. The first contention here is because each line card has a group of odd and even ports. Okay. Now the odd and even ports have to contest because they are mapped to the same core on the gearbox. Okay. Let's say on Babbage, the Babbage 0 chip, there are 2 cores. Now that core is mapped to the 5-core one, for the 4 services. Now, once that contention is also fought between the odd and even pair, then like this, like the drawing that you're seeing right now, this is for line card 2. You will have similar such drawings for line card 3, line card 4, line card 5, line card 6. Now, when multiple such interfaces are mapped, then we have to see, okay, if they have the odd even pair contention is over, then we have to see from all these line cards in one hardware pool, I can only have 18 maximum logical ports.
But 18 is more than 16, right? So 16, they already said that 16 are the total number of the interfaces, right? If we
Correct.
count that.
Yes, but
And
now
2 are, okay. Yeah.
but 16 are those transceiver slots. Like 2/1, 2/2, there are transceiver slots. But now each transceiver can be broken into 4 such lanes. 2/1 can become 2/1/1, 1/2, 1/3, 1/4. Right. So 16 transceiver slots can go up to a maximum of 64 possible interfaces.
Okay.
So that's where the limitation is. We can't accommodate 64 logical interfaces. From the 64 breakout, I can only handle 18.
Okay, that way. Got it. Yeah. Thank you.
So, Sachin, does that help answer the query?
Yes, I'm just wondering what is the speed at which I can use all the interfaces.
Sorry, what is the question again?
So if I put interface at 200 G speed, then 2/1/1 goes. Let's say I'm taking this as an example, 2/2/1 as an example. If I put that in 200 G speed, then 2/1/1 goes inactive. Right?
Correct.
But if I put that in 100 G speed, also 2/1/1 goes inactive.
It goes into inactive, correct, because you have a transceiver inserted in 2/2. So the assumption is possibly you will use other 2 lanes also.
You use other two.
Other 2 lanes also in 2/2.
No, Sachin, what I think, your question, right? That same question I was, was in my mind. If I want to use all the physical interfaces present in the line card, right? That is your question, right?
Yeah, I think I just say 100 G4 will be able to maybe use it. 100 G4.
So in that case, because we are having the backend limitation, so we can use, if we use each physical interface at the speed of 25 gig, then we can have the all the physical interfaces.
I think not 25, 100 G4. I think if you say that 100 G4, maybe 25 is also there. No, 100 G4 is the one where you can use all the interfaces, because every other one, if you see, and maybe 40G also, because every other one 2/1/1 is going inactive.
Yeah. So one thing what we were thinking of, right, was that this requires us to sit down and understand a lot of things. So while that takes time, the TOI that Ashwini shared has all the permutations listed. It has all the permutations listed, so that if a customer were to reach out to us and understand, we can look at all these different permutations to understand which goes into an active. So we may not have to remember all these things. It's important to understand this limitation, but the TOI just helps like a go-to page.
Got it.
Because understanding this, right, will take another 2-3 hours. That's why.
Agree.
But like you said, I don't think all the physical interfaces can be used anyway, even with 100 gig 4. Yeah, okay, yeah. This 100 gig
Yeah,
4,
that
yeah,
are
it's
logical.
is
Yeah.
yeah, they are all logical and it can be, yeah. But still, even though 2 to 4 is inactive, we are still using the SerDes link for that. So it must,
Yeah,
yeah,
that's the thing. Yeah. I'm just wondering what is there. I got it. I did not realize that is there.
yeah. Yeah. The major thing that we need to remember in this setup is that the operand pairs within the line card uh, operate as pair of 28 and 56, QSFP 28 and 56, which is 100 gig and 200 gig. They will share the hardware resources. And another one thing is that uh, there is a possibility of 6 interfaces in total uh, between these two, which is 2/1/1, 2/1/3. I'm just taking a 2/1/1 and 3 because 2/1/2 will work with 2/1/1 and 2/1/4 will work with 2/1/3. So even in the output, we can just see the odd interfaces shown, that it will go inactive, which implies that the other two also will go inactive. So that is one thing. Like, since QSFP 56 is higher speed, all 4 can be taken into account. So 4 from the even side and 2 from the odd side, which makes it 6 interfaces. And out of these 6 interfaces, only 4 can be active because only 4 SerDes is can be accommodated for this particular core. So these 3 needs to be remembered for Glacier. So in case of sorry, so in case of other form factor, which is 8D or 8P, even this should be overcome. So we have 8 lanes, and we have 8 SerDes. So this should have gotten reduced. So if you see, we don't have this chassis, but there is also TOI for the TOI, same TOI mentions which are all the interfaces will go inactive or active for that particular line card or for that particular speed. So
But in this case here, it's slightly more straightforward because between the transceiver and the gearbox, we have 8 possible lanes, and between the gearbox and the phi, we have 8 services. So it's not very complex.
yeah, pretty much they most of the links are going to be up. That's what. Right. Given the number of lanes that the speed is using, like rest of them are all going to be up. So that can be checked from the TOI as well. It's pretty straightforward here.
But this is now, what Ashmi is talking about is the odd even contention. But even after this is sorted, we still have the TH3 limitation of 18 logical ports per port. So that limitation is still there. Yeah. Okay.
So yeah, the points to remember across between these two slides is that switch card is shared across all the LCs because the ASIC is there, and 8 logical port pools as per the picture. We had 8 pipelines, 8 pools and 8 pipelines, and first for 16C, 1600 gig ports, 736816C, it's going to be 8 pairs of QSFP 28 and 56, which we talked about just now. And for for QSFP DD line card, that is Grinnell line cards, it's going to be 4 QSFP DD or 4 OSFP ports, which are straightforward mapped to the ASIC with 8 SerDes in between them. So that's one thing. And after all this port interfaces contention is over, we have the logical ports per pool, so that needs to be taken care of. At the maximum, 18 can be configured logical ports per pool, and yeah, like I said, for the 16C, there are going to be like two on the odd side and four on the even side, four interfaces. And this makes us six interfaces in total, out of which only four can be active per pair. And see, here we have six interfaces, but QSFP-DD, we still have all the eight interfaces. QSFP-DD and OSFP, we still have the all eight interfaces because this number of services equal to the interface lanes. Okay, so this is the TOI that we were referring to for the speed limitations and the interface convention. So we can make use of this one. I have pinged this in chat. Yeah, so if Glacier is okay, then let's move on to Monterey. Sorry. Yeah, so as mentioned in the previous slide, first few slides, we know that Glacier uses TH3 already, which is 256 SerDes, and Monterey uses TH4 chip, which is 512 SerDes, and this throughput for that is chip capacity is 25.6 TBps. So that can also be seen as 64 cross 400 gig ports. So each port, there we had Blackhawk 4 core, 5 core. Here we have one Blackhawk 7 core, and these Blackhawk 7 cores has 8 SerDes, and each SerDes can again operate at 50 gigs, 25 gigs, and 10 gig speeds. So it's going to be pretty much the same with comparing to the Glacier, the same SerDes speeds and how the lanes can be operated with that. Yeah, so again, this is very similar to Glacier. This is also a 4-rack unit chassis with one switch card, one supervisor, hot swappable fans and PSU. So in this case, only fans and PSUs are in both Glacier and Monterey. Supervisor and switch card are not hot swappable, but the fans and PSUs are hot swappable. Yeah, and even the line cards. So with the line card types, there are 3 different line card types here. Payable line card. Here we don't have the need for gearboxes or retimers. So we don't have that concept here. And fan shell, this is another line card, sorry. This is another line card with QSFP DD ports. And this line card supports Maxic. And there is one more line card with Granite. This is also 400 gig QSFP DD ports. So these are both basically the same. They are except with the Maxic, we need retimers because the throughput needs to be slightly lowered because of Maxic usage. Other than that, yeah, this is payable line card is similar to the 7368 16C. This is also 7388 16CD, and yeah, there are other 2 line cards. That's it. So this is how the Monterey chassis are there. Looks like the line cards are eight line cards, and yeah, each operating at 400 gigs or 200 gigs. The speed is mentioned here. The supervisor is this side, and the switch card here can be removed from the rear side. Because in Glacier, we had to remove all the fans and fans before we reach the switch card itself. But here, the switch card is on top above the fans, so we can easily remove. That doesn't mean that it is hot swappable. It is still not hot swappable, but it can be easily removed from the rear side. That's it. We don't have to. It doesn't change the cables just because we are removing this.
Sorry, just one correction. In Glacier, if you want to remove the switch card, what you would first do is remove the line card, and then you will have access to the switch card. So when you do that, you have to actually remove the transceivers and all the cabling, and then pull out the line card, access the switch card, and then put back the line card again. But in this case, in Monterey over here, the switch card is accessible from the rear, not in the front. So if you want to access the switch card, you no longer have to go via the line card. You can go from the rear when you pull out the fan card of the PSU and access the switch card, which also means that you don't have to worry about pulling out the transceivers from the line card and cabling and recabling things again. And that's a big change. Yeah.
Thank you, Sajid. Oh, yeah, this is some of the details about the switch card. This is 7388 switch card. And similar to Glacier, this here as well, the switch card runs the ASIC, TH4 ASIC, and it also carries the fans and PSU. Like we said, it can be removed from the rear side without any cable changes. Okay, so, oh yeah, okay, this is the base system with all the fans and PSUs plugged in. And, oh, sorry, why is it? Okay. Yeah, it again reiterates what's happening. Sorry, I don't know. Okay, so it again reiterates that there is no disruption to cabling on the line card modules, and the fan modules are hot swappable, and we don't need to untrack the entire system for removing the switch card at the supervisor. Okay. Okay, these are some details about the supervisor, which are very self-explanatory. It has USB ports for memory devices and x86 CPU, 512 gig SSD and EOS logging, and it has all the LEDs for the status checking, switch card, PS, and fan and all. Okay, so this is about the Pebble line card, uh, which is the 1600 gig ports, or it can operate a 16200 gig ports. So you remember in Glacier we had pairs of QSFP 28 and 56, but here it is just QSFP 56 everywhere. It's going to be there in pairs here as well. Uh, so it supports, this is a Blanco transceiver, so it can be inserted so that we can make use of the odd interfaces as 200 and 200, and we can make use of the interfaces as act as 400 gig speed, and there are no retimers as usual, and hot swap is allowed, and the handle is there to eject and insert the line cards, pretty similar to Glacier, almost similar to Glacier. This fan shell line card is again for eight ports with QSFP 56 ports. It can act as 40 gig, 200 gig, or 400 gig. QSFP DD ports, and this is with MAC6 support. So we might need gearboxes or retimers here. And this is also hot swappable with no power off, and also the same ejector is there for this line card as well. Again, this is another type of line card, granite line card. No retimers for this. So it's directly similar to previous all other line cards. It's connected directly to the TH4 ASIC. It operates in all the below speeds, 100, 40, 100, 200, and 800. Okay, so again, port mapping here is we have all the line cards mapped to 16 different pools, and there's one-to-one mapping between the line card and the all other 8 pools here this side, and 5, 6, 7, 8 is mapped to other pools in this side. So similar to Glacier, there's going to be the pools and the limitations are going to be there. Yeah, but we don't have a Monterey chassis, so that we can take a look at that. But yeah, the it is pretty similar to Glacier, but just the number of pools have got increased. Okay, so as I was saying, the 16 CD line card is grouped as paired as two QSFP 56. QSFP 28 is not there in this case. It is again similar to our Glacier line cards, where there will be a QSFP DD individually mapped to the ASIC. So this is again the pair 2/1 and 2/2 will share the hardware resources. But if you take a look at the number of SerDes here, because there is no retimers also, there's one whole block missing in the middle for this Monterey. It is directly connected to the 5 core here. And the number of SerDes link has increased. So it is 8 SerDes link shared between these two interfaces. So if we take a look at here, it is gone like this. So 8 links are shared across this one. Similarly, all other interfaces also share the 5 core in pairs, and the speed also it is similar to our Glacier chassis. Let's just take a look at one of these speeds. When we say odd 1/1, so if we had Glacier, we had these limitations where two odd interfaces and four even interfaces. Because even interfaces had a slightly higher speed, that is 200 gig, we allocated 4 there. But here, both are same, both are 56. So we are allocating more on the odd side of the pair. So here, odd interfaces will be 4. It switch places now for 4 odd interfaces, and 2 even interfaces can be active. That is possible, but again the same limitation, per pair only 4 can be active. uh, so if you take a look at the speed, this is odd/1, which we can call it as 2/1/1. If we operate at 200 gigs in 4 lanes, let's see what happens. 200 gig in 4 lanes. So all these four of them will go, because it's supporting the 2/1/1. And it doesn't mention anything about these 4 interfaces, because we can still use them. That is the reason. It has exhausted only 4 of these services. The remaining 4 are still on, so we can make use of 2/2 as well. That's why it just says or 2/4 goes inactive, and it doesn't mention anything about the event side interfaces. So similarly, if we take a look at 50 gig, if because it go event side goes off, so 50 gig is one, right? So when we take a look at this, so one service is used. So there are still possibility that um, these 3 can be active. So if these 3 are active, remember we can use 4 of the odd interfaces, and 4 per pair only can be active. So if these 3 are active, 4 links are already utilized. So this one goes inactive. The whole event side goes inactive. That is, even in the event side, it just mentions 1/1 and 1/3 is inactive. Any questions? I think I went a bit fast here, but just let me know if I need to slow down a bit. Okay. Yeah, it's still the same on the 8B side as well. Maybe I can zoom in so that you can see. So they are mapped with, they are straightly mapped with the 5 cores. So they are sharing. There is sharing of resources between these two QSFP-DD pairs. It's still the same for 2/1 and 2/2. Core can be active for this. Oh, sorry. All right. Uh, yeah. In the DD side, I think most of them can be active here, except for the one which uses all the 8 lanes. The other goes inactive. Not this is not the diagram. Yeah. If we use all the 8 lanes, then this side, event side goes inactive. Otherwise, there are certain instances where some of the event side interfaces can be active as well. So we can refer to this TOI 7388 speed configuration and behavior. So that will explain a lot more on interfaces going active and inactive. I'll share this in the chat. Okay. Okay. So again, switch card is shared across all the LCs, and there are 64 logical port pools. So 4 logical ports can be active per pool. And again, as I reiterated, it is a pair of QSFP 56 ports in 16 line card model, and one QSFP DD port straightly mapped to the 5 core in the 8 line card model. Each pair of 56, as I said, on the odd side it is 4 now, and on the even side of the interface it is 2. So 6 possible interfaces are there. And on the QSFP side, so it again mentions on the odd side 4 interfaces, and on the even side 5/7, 5/5 and /7. 6 and 8 depends on the speed configured on /5 and /7. Okay, so as I showed in lab, this is one of the commands which is very helpful. Sorry, this keeps moving. Okay, this is the one of the command which helps us in looking at the pool status. Show hardware logical port pool. This is very useful. We can see how many are configured, and I also showed you how what will happen if more number of interfaces are configured than the maximum allowed limit. So it will just throw a start out of logical ports in the newer codes, and back in 4.25 it shows as hardware resources full. So yeah, this is the slide which shows the error, and these all ports will have impact on starter logical port. And even here we are changing the status of the interfaces on ET2, 3, and 4, and we are not touching any of these interfaces. So just because these are configured as 25 gig, all these interfaces are impacted, and it throws out this error. Also, so remember how I told the lower number of line cards will get preference, even though the higher number of line cards are installed in the chassis before it. That will cause, like, assume we had line card 5 inserted in the chassis already and we had some configuration and working with it. Then there is a need of line card 2 to be inserted now. And according to the limitation or the working of the model device, line card 2 should be given the highest preference. So as soon as the line cards are inserted and the interfaces are configured, interfaces are connected, they are going to come up. So in order to, that will cause, if 2 comes up and 5 is not affected, then it's not a problem. But if 2 is coming up and 5 are affected, 5 interfaces are affected, which are already carrying traffic, then that's a problem. It's going to cause some loss for us. So in order to stop that, we are configuring this under interface defaults, where if a lower number of line card is inserted, until we configure them explicitly, the interfaces of those lower number line cards are going to be down. Even though the card is inserted, uh, we need them to be down until we explicitly configure them. So this is safeguarding the interfaces which are already higher, interfaces which are already up. So this is configuration that needs to be put in when we are inserting the lower line card.
So just to add to what Ashwini is saying, by default, it is no shut, which means that any interface, if there's a transceiver inserted, it comes up, and what happens is when it comes up, it also requests for those hardware resources. So that happens by default. And then, like what Ashwini mentioned, if it's a scenario where um, it's a lower numbered interface which has to now request for that resource, it can cause a higher number interface to become inactive. And if that higher number interface is actually carrying traffic, then that will become inactive. That will cause a huge outage. Right? So this is the default behavior. So we can, by configuring this, what you're just telling them is, what you're telling the device to do is, any interface that comes up is explicitly shut down. So it doesn't. It means that it's not requesting for any hardware resources until the user goes to the CLI and says no shutdown. Yeah, Shri.
Yeah. Okay. Again, like we saw at the lab. So in the lab, when we configure a certain speed on one such interface speed group, it is going to flap all the other interfaces in that particular speed group. And if we are configuring an incompatible speed, which we also happen to see in the lab, it shows either error disable. It error disables that port as speed misconfigured.
So these are very similar to what you would see in TH3 or TH4, where changing the hardware speed group will cause all the interfaces to flap. And in the second case, if you want your front panel interface to run at a specific speed, then the SerDes also needs to support that speed. And if it does not, then you will see a speed misconfigured error, which also means that to correct this, you will have to go and change the SerDes speed. Only then it can support the front panel speed. So same like your TH3 and TH4. Yeah, Ashwini, yeah,
Yeah, again, to reiterate, the lower numbered interfaces are receiving higher priority, and higher number interfaces are having lower priority by default. And as Sujit explained before, there is this is no shutdown or enabled by default. So in order, as soon as we insert the lower number line card, it's going to come up. In order to stop that, we are going to configuring. We will need to configure the interface defaults configuration, and they will be only be able to become active only when the hardware resources is requested and when we enable it explicitly. So that when they come up, they are not going to request for the hardware resource, and they will stay inactive until we ask them to become active, like until we configure them to become active. These are the references and links for all the docs. So that's it. Any questions?
So just to summarize for everyone here, I think one of the key objectives of the session here is to understand that this is a slightly different concept of a modular. It is modular because you have different field replaceable units, but your supervisor and your switch card are not thought so. Right? So that's just single point of failure. It's also different because unlike other modulars, which have multiple line cards and all the line cards have ASICs, over here, none of the line cards have your ASIC. The switch card has your ASIC, and there's only one ASIC in the entire chassis. So, like Ashwini pointed out earlier, each line card would have different ASICs, but over here only one ASIC is there per chassis, which means that there is a very big chance of oversubscription. right? Which also means that you have a possible, uh, you have many interfaces that can come up, but there are limitations because the number of services can get oversubscribed. So, which means that it's also a little different because there's a concept of an L1 topology, a layer one topology. Now, in earlier modular chassis, they were all fixed, right? If you brought or introduced or brought down line card 2, it would never impact line card 3, 4. Right? So then there was no dependency. But over here, because they're all sharing the same resources, there is a dependency, which means that line card 2 is dependent on line card 3, 4, and 5 because they're all sharing the resources. And this is also because as the device is brought up, there is no fixed L1 topology. The L1 topology can keep changing based on the interfaces up, the transceivers, and the speed. So this was one very big change that we see in Glacier and Monterey. And because of this, right, a lot of customers might be confused as to why are they seeing these limitations. So I hope one key understanding is to understand why there are limitations on the number of logical ports, but don't worry about remembering all the permutations. The two TOIs that Ashwini shared, which is also in the slide deck, they are very useful. They have listed down all the possible permutations that you can come up with. So should a customer actually reach out to us, the TO has all the information for that. So don't worry about that. Yeah, the two TOIs, one for Glacier, one for Monterey, they can become your to-go places for any such L1 topology or inactive logical port questions. Any questions?
Oh, maybe not. Sorry, I saw I agree. Oh no, no, definitely. I'm sorry. I saw this. Right? Oh, yes, absolutely.
So if no further questions, then we have reached the end of the session. Thank you. Thank you all for joining.
Thank you, Ashwini, for that. That was really, really nice. Thank you.
Thank you, Sujit. Thanks. Thanks, everyone.
Thanks, Ashwini. Thanks, Sujit.
Thank you.
Thank you, guys.
Thank you.